So now that we've been granted the appropriate permissions, now let's start to actually query some data and load that data into our workspace. And for that, we're going to go back to the Knowledge Center, but this time we're going to go to the Use Samples immediately. And this will actually help us create some external tables automatically and query data that lives in an external data lake with our Azure Open Datasets. So once again, we're going to select our existing pool. We could be using built-in, but let's leverage our dedicated SQL pool for this session. Click on Use Sample, and you can see that once again, it's automatically generated this script that will actually create the external table and the associated objects and allow us to query that data in the data lake. So just to review this script real briefly, the first object it creates is our external file format, and we'll run this first. And what this does is basically just lets our pool know what type of data or file format to expect. So in this case, our Azure Open Dataset is in the Parquet format. The next request here is going to create and define our external data source, which once again, defines the location where that data is going to live. In this case, it's open source taxi data living in our Azure Open Data blob storage account. And then finally, this last script creates our external table. And this is actually the object that we are going to query and actually will live inside our SQL pool as well. And that's one of the big advantages of using an external table to query data living outside Synapse. It creates this external table object, which persists, which we can then not only query, but then use it like a table for other things within the dedicated SQL pool. We can join it with other data. We can put some security permissions over it. There, of course, is going to be a little bit of a performance loss because the data isn't living right inside the managed storage where we can have all of those great optimizations and compressions on it. But we didn't have to load this data at all in order to start querying it. So we can have this query start running. Like I said, depending on the different regions that your workspace and your SQL pool are in compared to the blob storage, and depending if it's your first time querying and a couple other reasons, the performance may be slower than what you'd expect in the SQL pool, but we've saved that time and not actually having to load this data in the first place to query it. So it's a really great use case for when you need to keep some data inside your data lake, whether it's to be accessed by other tools or you want to keep it in its raw file format, or for accessing data that may live in other data lakes. We didn't have to include any security permissions here on this data source because this is an open blob storage, but you can also authenticate using managed service or using like a storage authentication key. So that can allow you to access, more private data lakes that might be in other organizations in your team, and just give you an option for if you can't actually move that data into your dedicated SQL pool in the first place. And you can see we were able to get our full set of results over this taxi data without having to do any data movement into our SQL pool. And if we actually navigate over to our SQL pool, we'll refresh the page, or we'll just go over to our external tables, and you can see we actually have this external table object now persisted here in our database. So you can, makes it very easy to collaborate, easy to keep track of, because now once again I can view this table, I can generate queries off of it right here from my SQL pool, and really in a lot of ways treat it like I would any other table available to me in my SQL pool. So now we've managed to query data in a data lake, living outside of our SQL pool. But what if you actually wanted to load that data into your dedicated SQL pool? Of course, like we said, that gives you some advantages, like being able to have statistics, column store indexes, results head caching being run over that. So for data that you're accessing very frequently or joining with really large data sets and complicated queries, you can definitely get a lot of value out of moving it right into the SQL pool. And really, there's a lot of different ways to do that. You have different options based off the tools you prefer to use, If you're already leveraging Spark, you can use Spark cluster and Synapse to do that. You can leverage our pipeline capabilities to do that. You can actually even use this external table to directly load that data in just by using a CTAS statement. But whether you prefer a code-based or a code-free solution, you've got a lot of different options. The one I want to show off right here is using our copy command, which is really kind of our newest way of loading data in. At this point, it's been out and about and fully GA for a bit now, but it really is one of the most performant ways, if not the most performant way to load a SQL pool, and on also the simplest. So go to our Knowledge Center, don't initiate the guided tour, go to our Browse Gallery, and then from here, SQL scripts, and then look for loading data in using the copy command. So we're going to look for the copy command statement, which is right here, load our New York taxi cab data set. We'll continue, same thing, look at the script, and then put it over our existing SQL pool. We'll open the script, and once again, we'll take some time to go through this script, see what's going on. It looks like there's a lot going on, but this is a relatively straightforward script. With the copy command, it's a little different than the external table format. You don't need to create that external file format and that external data source first. You can just run the copy command, but you do need to have the table created ahead of time in order to load the data in. So that's really what most of this script is just creating the different tables that we'll be using to actually load this data in. The big thing that I want to call out that does relate to performance and optimization is, as you may know, every table in a dedicated SQL pool has both a distribution option and an index option. And this really just relates to how the data is stored in our managed storage, whether or not we're building it over indexes and in a columnar format versus a row-based heap format, and also whether or not we're distributing it based off a specific hash key or a or just a round robin kind of even distribution. And so based off whether you're looking for maximum loading performance or maximum query performance, and based off whether you kind of know the queries and the distribution keys you'll be going to be running over, you have a couple different options. The default ones we have here are a round robin distribution, which is great for minimizing data skew, especially if we don't know the types of queries we're going to be running yet. And then clustered column store index, which is just a great default option, especially as the data we start to bring in more and more rows for ensuring that you have good compression. And we can talk about more of those options you have later. I think the only other thing to say here is that if you're looking for maximum loading performance, you can also choose to do a heap table here instead. That will basically just be a row-based or row groups as opposed to the columnar distribution. And that'll give you maximum loading performance. And then later, you can run a CTAS statement to switch over to a clustered column store or even an ordered column store index if you want. But we'll just keep everything on the defaults here. So you can see we're creating all of the different tables for our New York taxi data we'll be loading in. And then after the tables are created, we can start to get into our actual copy operations. So I'll start letting this run just so it can start the loading while I explain this copy statement. And you can see here that it's actually very simple, which is part of why we love to use it, is because it's both simple, but also very performant. So all you need to do is identify the table you're copying into, where you're copying from, in this case, our New York taxi blob, and then the file type, CSV. We're using a comma terminator, an empty field quote, and then we're actually, another great thing here is we're using a label as part of this copy operation, and that will allow us to actually track this data as well. While this loads, if you go back to the Knowledge Center, you can also find in our gallery for our SQL scripts, you can find other scripts that are actually about monitoring the execution of your copy statement. And so we won't open this up all the way, but you can see here that you can actually track labels and other options of that copy statement to actually track those loads as it happens. And just by running this as part of a stored procedure, you can actually get a really good view over what's going on in that job. We won't run that now because we're loading a a relatively small amount of data, we'll just flip back over to our data hub and look at the execution of this as it runs. And so you can see that we're creating these tables, and then we'll be loading each of these files, each of these tables from these files into blob storage in turn.